Good evening, sir. We are from STA108G1 and we are Group 5. And in this video, we will be presenting our statistics and probability project entitled A Study on Variables, Weight of Newborn and Gestation Period of Pregnant Mothers, the Descriptive Measures and Simple Linear Regression Analysis. So throughout this presentation, we will briefly discuss the background of the study, the methodology, the results, and finally the conclusion and recommendations. So before we begin, allow me to introduce my group members. So first we have Andrisus Janamail and Ashton Vellun, which is me, Muhammad Itsni Kuzairi, and Estelle Rian Nelson Bito.
Introduction. This study investigates how maternal smoking during pregnancy, alongside gestation length, impacts newborn outcomes including birth weight and body length. While global awareness programs highlight smoking harms, uptake remains high with maternal smoking in pregnancy, reaching 8% in Europe, the highest regional rate worldwide. Prenatal smoking is linked to shortened gestation, preterm birth, and reduced birth weight alongside elevated risk of stillborn, sudden infant death syndrome, long-term cognitive and behavioral difficulties, and respiratory illness. This study also serves as a valuable application of core statistical concepts, turning theoretical knowledge into practical analysis. Methods including distribution assessment, dispersion comparison, correlation calculation, and regression modeling are used to derive evidence-based insights, helping to build a clearer understanding of key factors that shape newborn health outcomes. Using data collected from 57 mothers, this research examines gestation periods ranging 30 to 42 weeks and birth weight from 1008 G to 4788 G. Its core objectives include analyzing data distribution, describing variables numerically and graphically, measuring the correlation between gestation length and birth weight, comparing outcome variations between smoking and non-smoking mothers, and building a model to predict birth weight from gestation period. The findings carry important implications. First is they confirm no safe level of tobacco exposure during pregnancy, including secondhand smoke, and clarify how gestation length and smoking status together shape newborn health. The work also demonstrates practical applications of statistical methods such as descriptive analysis, dispersion, measurement, correlation testing, and regression modeling.
Alright, now I will explain the research methodology used in this study. This study adopted a quantitative research approach which focused on collecting and analyzing numerical data to answer the research question. The study used secondary data analysis, meaning the data was obtained from an existing datasheet rather than collecting new data through survey or interviews. The data set consists of 80 student respondents, and then the research focused on three main variables, which is gender, academic program, which is classified as science or arts, and academic performance, which is measured using students' CGPA. Finally, the collected data was analyzed using both descriptive statistics to summarize the data and differential statistical tests for differences between groups. Alright, next, this slide shows the variables and the statistical methods used in the analysis. There are three variables in this study. The first variable is gender, which is a categorical variable with two categories, male and female. The second variable is academic program, which is also a categorical and consists of science and arts programs. The third variable is academic performance, which is a numerical variable measured by students' CGPA. So for the data analysis, we first conducted descriptive statistics. These include frequency and percentage to describe the distribution of categorical variables, and mean, median, mode, standard deviation, and range to summarize the CGPA data. We also use histogram and box plot to visualize the distribution of the data and identify any possible outliers. And then next, for differential statistic, we perform an independent sample test, t-test, to determine whether there is a significant difference in the mean CGPA between two independent groups, such as male and female students. All statistical calculations we carry out using Microsoft Excel. And then, that concludes the research methodology. Next, I will present the result and findings of the study.
So moving on, this slide presents the smoking status of the respondents. Out of 57 pregnant mothers, 35 were non-smokers while 22 were smokers. Therefore, the majority of the respondents did not actually smoke during pregnancy. Now to the distribution of quantitative variables. So this histogram shows the distributions of the three quantitative variables, namely the gestation period, newborn weight, and newborn length. So most gestation periods were between 37 and 40 weeks, and most newborn weights were concentrated around 3,000 to 3,500 grams, while most newborn lengths range between 45 and 55 centimeters. So overall, the distributions appear to be approximately normal, providing a good overview of the characteristics of the data. Next is the measure of skewness. So skewness is used to determine whether a data distribution is symmetrical or skewed to one side. So if it's skewed to the left, it's negatively skewed, and when it's skewed to the right, it's positively skewed. So based on our analysis, the gestation period has a skewness value of negative 1.310, while newborn weight has a skewness value of negative 0.511. Since both values are negative, both variables are negatively skewed, meaning the distribution have a longer tail towards the lower values. These results are also consistent with the histograms presented in the previous slide.
Hi, I'm Mohammed Izzy, and I'm going to talk about central tendency. In this slide, the table outlines the center points of our quantitative data. The average gestation period for our sample of mothers is roughly 38 weeks, with the most frequent duration being 40 weeks. Looking at the newborns, the average birth weight is approximately 3,308 grams, while the average structural length is right around 50 centimeters. This value gives us a baseline profile of a typical pregnancy in our studies. In the next slide, we are going to talk about dispersion. Dispersion is the spread of our data. By looking at this table, we will notice a major difference in variability here. While the gestation period is highly stable, ranging only 12 weeks from earliest to latest, the newborn birth weight shows a massive spread. Birth weight stretch from across a range of 3,780 grams, from a low of over just 1,000 grams, into as high as almost 4,800 grams. This indicates a significantly higher case-by-case variation in weight compared than in baseline pregnancy duration. In the next slide, we are going to talk about central location or quartiles. This is to find where the bulk of our data sits. That's why we use quartiles. For gestation, the middle 50% of the mothers give birth within a narrow, predictable 3-week window between weeks 37 and week 40. For birth weights, the middle 50% spans a 730 gram window. This perspective also highlights our extreme outliers, specifically noting the severely low birth weight and short gestation period tracked in observation number 35. Up next, we are going to talk about the coefficient of variation. Because week, gram, and centimeters are all in different units of measurement, we have to use coefficient of variation in order to compare them. The results are clear. Newborn length and gestation period have incredibly low relative variability, both sitting around like 6%, which proves that physical body length and pregnancy timelines are highly stable. Tightly bounded biological traits. Birth weights, on the other hand, are highly volatile with a coefficient variation of over 20%, which shows that weight fluctuates drastically depending on the external factors. And then we are going to talk about correlation and regression analysis. We evaluated the direct relationship between a mother's gestation period and her newborn's weight using the Pearson correlation coefficient. Our calculation yielded a weak positive relationship of approximately 0.342, while the positive sign confirms the obvious rule that longer pregnancies generally lead to heavier babies. The weakness of the correlation indicates that time alone does not guarantee a healthy birth weight. Other crucial environmental elements, such as maternal smoking status, plays a significant role in modifying these outcomes. That's all from me.
Conclusion: this study confirms the gestation period influences newborn weight, but smoking during pregnancy creates notable differences even at the same term. At 42 weeks, babies of smoking mothers weigh 5,264 grams versus 3,640 grams for non-smokers, while at the shortest recorded 30 weeks, weight also differed between smoking mothers. Correlation and regression analysis found only a weak positive link between gestation length and birth weight, meaning longer pregnancy alone does not guarantee normal weight. These findings reinforce that no level of cigarette use during pregnancy is safe, as smoking poses clear risk to birth outcomes. This work also demonstrates how statistical tools turn raw data into meaningful insights. Beyond collection, techniques like graphical presentation, mean variance, quartiles, correlation, and regression help summarize patterns, compare groups, and clarify how variables relate to one another.